blog published a copy of this letter that Amazon sent to their customers back in April. And essentially, someone had found that an image had been shared with the public that had authorized SSH keys baked into it. So the publisher of this image could potentially have full access as root to anybody that chose this machine image and spun up instances of it. So this also reinforced to us that this is something we wanted to look at more closely, and this is why we built these tools to go ahead and evaluate large numbers of machine images to look for things such as SSH authorized keys that shouldn't be there. Jeff, you want to take over from here?
Yeah, sure. Okay, so there was, after we were accepted for this talk, there was a group in Germany, some postdoc researchers at a university there, that released some research that's very similar to ours. They also released a tool that scans AMIs in a very similar fashion to what we do. Their tool is a Python script that essentially you have to run on the instance itself, whereas our tool interacts with the Amazon APIs to spin up instances, SSH to them, scan them remotely, and turn them down. So they're similar, but the approaches are slightly different. And we've scanned more images and have a little bit larger data set from our tool. But I just wanted to highlight that there's other people working on this, and it's possible that there's others that aren't publishing it. So this is probably something that's being done in the wild. So when creating a public AMI or an AMI that you share with other users, there's a number of ways that you can accidentally leak your own credential material. On the file system itself, you may have your Amazon Web Service certificate and private key. You might have SSH key pairs, either an authorized key that Ben mentioned, or an actual identity key. You might have SSL certificates and private keys that are on the image. You need to be conscious as a publisher of an image what you're putting out there, because once it's public, it is truly public, and anybody can access these images and search for these sorts of credential materials, and that's essentially what we've done. There's also other ways to leak information. Bash history files is a big one. If you run the image as an instance yourself and done any sort of work on it and then made a public image out of it, that bash history might expose that, and it might also expose some of these credential materials that you've used. Files like bashrc, bash profile often contain environment variables that are set to these values for scripts to access and things like that. So we looked for these as well, and then also vim info files. Occasionally there's a chance someone might be trying to clean up and go in and edit a file to delete it, but they search for that, and their vim info stores that search for that string. So it could be there as well. And then we tried to do a little bit looking for signs of a malicious AMI. This is primarily the SSH authorized keys. There's possibilities for rootkits, Trojan binaries, reverse shells, connectbacks, those sorts of things. With the PV grub kernels that they support now, you can run your own kernel on EC2. So you could backdoor the kernel directly if you wanted to. There was a talk today in SkyTalks. Ansh with 303 demonstrated an AMI image that essentially would, when it was launched, would phone back, download a piece of code, execute it, and he'd get a interpreter shell from it anytime somebody spun that instance up. So that's also related work to this. So there's been other work on malicious AMIs. Ben mentioned some of the work from 2009 from DEF CON 17. This is something anybody who's looked at Amazon Web Services thinks of this, that these images are public, and there's not much verification of who the publishers are and what their intentions are. And in a lot of cases, it's really difficult to detect malicious intent and malicious behavior. So we undertook a project to try and gather some data surrounding this. How easy is it to find victims? What kind of instances are they running it on? What regions are most popular? And kind of most importantly, Would their security groups, which is similar to a firewall policy for an EC2 instance, would those be configured sanely? Don't allow the world to connect to your SSH ports, for example, which would be effective at being somewhat of a hedge against an AMI that has a Trojan SSH daemon or a pre-existing authorized key. And then we also released our tool, developed our tool that we're releasing to perform large-scale scans of images within the cloud. So the name of the tool is AMI Exposed. So it's kind of a pun on AMI and asking a question, and the tool seeks to find the answer. So it's a framework essentially for scanning AMIs for these credential leakage patterns. I tried to follow a sort of similar model to what Metasploit does, although my code's nowhere near as elegant and nowhere near as capable as the stuff they've got. But in a similar vein, there's test modules that you can plug in to add new functionality with very little code and leverage the existing classes, the existing object model to add new tests. So at its heart, it uses Amazon's API to automate the retrieval of a list of images, defining your scope of your tests. I'd imagine common use cases would be testing all images that I own, maybe before I make them public if I'm planning to do that. As a penetration tester, you might be interested in, testing all images that are owned by a specific client, to see if you can find any of their credentials being stored publicly. So once the scope's generated, we basically iterate through all the images, launch an instance, run tests over SSH, and record findings to a database. The tool is released on our website, secureworks.com/research/tools. There's currently a little bit of a problem with the file that we're going to get corrected probably Monday morning. So if you have any trouble downloading it in the meantime, I apologize for that. As I said, there's several test modules included at release. There's 10 to be precise. They check for the things that we've been discussing, and I'm not going to keep repeating all these different vectors. It also tests within system files, so it'll search for a number of files and then search within them for specific strings. These strings are all definable by a configuration file. You can just pop a regex in there, and it'll search for that regex, and you don't necessarily even need to write a new module to add a new string that you're interested in. So here's kind of the flow of how it executes. Up at the top there, we've got our scope definition phase. You can either do this manually just by going into the AWS console and putting tags on images that you're interested in, or there's a tool that's included called tagimages.rb that allows you to define larger scopes, more easily. You can't go and click through thousands of images. Again. Query for the tagged images, iterate over them, and obviously we wanted to thread it. I should mention this is all in Ruby. I didn't even say that, but down the right here we have some of the gems that are used. So we're using the threaded collections gem for managing threads, and then we're using the official Amazon Web Service SDK for Ruby, which was released about 3 weeks ago. So I actually kind of wrote 2 versions of this tool. I spent a lot of time writing one that interacted directly with the SOAP APIs over, parsing the XML to my own object model. I was just about done with that and about to do our large-scale scan when Amazon released their own SDK. It was much more elegant, much cleaner, much more efficient. So I ported my code over to adopt that rather than duplicating that functionality. They've also been improving it at a pretty rapid pace. So there's been a couple of releases that have made minor adjustments and bug fixes just in the past few weeks. So once we launch the instance, we have to figure out what account we're going to use. So that's down there on determining SSH username. So we try and log in as root. If that fails, we try and parse any response that comes back. A lot of times you log in as root and you get a response that says, please use ABC instead of root. So we try and parse that from the banner. And then if that fails, we just iterate through a list of usernames that we've discovered are commonly used out there. So generally we're pretty capable of being able to determine the username. I clicked ahead. And then then we run our tests. So we go through each of the test modules, load the module, run it, and record all the findings in the database. So we're using NetSSH for the SSH components and Active Record for the database component. So I'm going to demo it. It's going to take a little while to run, so we'll talk a little bit more about the internals while it's running. So give me a moment here. Apologize for the delay. Okay, you see my screen? Yeah. Okay, so out here, this is the AWS console. I'm showing 3 images. These are all images that I've created. I'm not going to show anybody else's data but my own. So 2 of these, this first one is a public image that I created that's an AMI that allows you to run Backtrack 5 within Amazon's cloud. And we'll talk about that a little bit more later. The second one is from when I was developing that image. This is a private instance, or a private image, but you'll notice I scanned it previously and it's marked as failed. As I was iterating through the process, I broke the SSH daemon on this one, so it starts, but I can't SSH to it. So I just wanted to show that it flags it as failed. And then the other one down there is one that I made just for the for the demo here that demonstrates some of these key material leakages. So I've got things there that look like real keys. They are real keys, but I'm not using them anywhere, and it's not live data. It's just for demonstration purposes. But you'll notice there's a tag on these, and 2 of them are in pending state, and that's how we define our scope. So the scope of this test is those 2 images. So let me just do this full screen. Whoops. Okay, is that still there? All right. So this is actually I'm SSH'd into a running instance on Amazon's cloud, and that's where I did all my tests from. So it's kind of interesting that I was using the cloud to scan the cloud for security problems. So it was all taking place in Amazon's infrastructure. So this is a directory where I've got the tool here. You'll see this tag images file that we talked about that allows defining the scope, and then scan.rb is really the main heart of the tool. So I'm going to go ahead and launch scan.rb. It looks a little bit weird here. My ASCII art didn't scale to this font size. So you see there it says it's storing logs for each AMI under a logs AMI subdirectory. Starting a test of 2 AMIs, I've got to configure for 13 threads, but it's not going to run 13 because it's only got 2 images. And then just timestamp saying it's scanning. So this probably take about 10 or 15 minutes. So we will go back and come check on this. I keep doing that. Come check on this in a little while. Okay, we got through this. Sorry, I lost my spot. Okay, so while that's running, let me talk about some of the things I did to expand the Amazon Web Service SDK. I basically just opened their classes and defined some additional methods to give me the functionality I needed to do this that they didn't provide, through the SDK. So we modified the instance, added some methods to interact with instances, run a command over SSH either via SSH exec or PTY, and then it's got a run test method that basically loads a test module, runs it against that instance. I'm going to go through these kind of fast. The slides are a little bit wordy, but that's mostly meant as a reference. I modified the image class to add another method there. Added some places to store parameters. We discovered that SSH user, and I need to store it somewhere, so I just stored it as a tag. Also, that test status, updates that tag that defined our scope and defines the results of the test.